On example 5 of this first section of Unit 6, I again solved for y, where I subtracted x from both sides and got negative x plus 3. And we're going to graph it, so that's a plus 3 and a slope of, again, negative 1. So it's going to travel down the page here and up as well. And we can draw our line for this. And then the second line, 2x plus 2y, I subtracted the 2x for both sides, and then I divided everything by the 2 in front of the y. And so that was going to give me y, and this is going to give me negative 1, and 6 divided by 2 is 3. Oh, you notice that they're the same line. So when I graph it, it's going to be in exactly the same spot. So where do the two lines intersect? Along the entire line. So they're actually the same line, aren't they? What does that say about the solution to the system? And be careful, the answer will not be all real numbers. So why wouldn't it be all real numbers? Right? For one reason, the answers are ordered pairs, but it's not every ordered pair in the whole world, because not every ordered pair on this graph is on the line. So it's only the ordered pairs that are on the line, but there's still an infinite number of ordered pairs along that line. We're not just counting the ones that you can see, but it extends up and down, and it can, includes decimals and fractions as well. So we say that there are an infinite number of solutions to that equation, to that system. We'll also have systems of linear inequalities. So remember that a solution set for a system of, a solution set for a system of two inequalities is a region that satisfies the first inequality, so remember it's a shaded area, and the second inequality both. So we must find the intersection of the two regions. So to find this, we're going to graph and shade each lightly and then find the common region. So example 6, y, we're going to graph, this time we're going to have a dotted line, right? We're going to put a 2. We have a slope of negative 1, so that's going to fall down. So I really need a kind of dot this now. And because we have that y, solved for y, remember it needs to be solved for y, is smaller than the line, we want the y's that are below it. So I'm going to shade this with with a pencil here. It's a little bit easier to do, so you can kind of see that. And then I'm going to graph the second one, which is y greater than 2x minus 4. So 1, 2, 3, 4. So there's my negative 4. And I have a slope of 2, so up 2 and over 1. So I'll do that a few times. And again, it's a dotted line. So I will, or dash line, however you want to do it, shade it that way. Now this one, again, this one now, y is above this second line that I graphed. So I would shade above it. And as you do it, you can kind of see the section of the line, the section of the graph that is in both of them. And that's going to be this section here. I'm trying to color this in really dark. So this area right there is the solution to the system. Now let's look at that one more time. Here I have x plus y is greater than or equal to 1. So we'd have that y. I'm going to subtract x from both sides. It's greater than or equal to. That's going to give me negative x plus 1. So it's a plus 1. The slope again is a negative 1. And this time it is a solid line. So this time it's a solid line. So I'm going to draw that here. And then it's going to shade because y is greater than. That means that I want the y's that are above the line. So again, I'll just probably kind of do that lightly right there. The other equation is x is greater than or equal to -3, so that's a vertical line through 1, 2, -3, and it's also equal, so it's a solid line. And I'm going to shade, because x is greater than, I'm going to shade to the right of that line. So here I'm kind of shading this way, and the place where they overlap is here in this section right there. So you'll have a little bit more ability to do that on your own and graph it.